It remains the largest helicopter ever made. Able to lift 40 tons of Soviet-made weaponry, the Mi-12 was more than twice as strong as any helicopter in the West. At the time, it was seen as a technological marvel, but was it practical or merely propaganda? This is an air show at Kubinka Air Force Base, the headquarters of the Air Force of the Moscow Military District. As always, helicopters feature prominently. These parachutists are being dropped from Mi-8s, one of the great Soviet workhorse helicopters. Since the 1950s, helicopters have had special significance for Russia and the Soviet Union. The helicopter is an ideal form of aerial transport in Russia's vast undeveloped land expanses and widely varied climates. In fact, one great Russian helicopter designer has said, the Soviet Union was specifically invented for the helicopter. This special affinity with a helicopter has led to an approach to its design quite different from that of the West, and it has led to a high level of skill among helicopter pilots. The first successful post-war Soviet helicopters borrowed heavily from the work of two American designers. One was the Russian expatriate Igor Sikorsky, who left Russia in 1919 during the Civil War. The other was Frank Piasecki, whose early twin-rotor helicopter designs led to the development of the famous Chinook. But the Soviet Union's period as an imitator of American helicopters did not last long. It set out upon a path of evolution that has made its helicopters unique in world aviation. In the field of large single-rotor helicopters, the Russians have no rivals. They also built and flew what is still the world's largest twin-rotor helicopter. Their application of the helicopter to Soviet conditions has been original and ingenious. And Soviet helicopter development started much earlier than most Westerners imagined. This is film never before seen in the West. It was shot in Moscow between 1930 and 1933, when Tsargi, the Central Bureau of Aero and Hydrodynamics, developed one of the world's first flyable and controllable helicopters. Russian helicopter development actually began much earlier, before the First World War. Igor Sikorsky and B.N. Yuriev experimented with helicopter design. Sikorsky fled the revolution and went to America, but Yuriev stayed on and joined Tsargi. In the late 20s, there was a major Soviet experiment with autogyros, but the really important development was this one. It was the Tsargi 1EA, the first Soviet helicopter to achieve true flight. The design was begun by Yuriev in 1928, but he left Tsargi in 1930, and it was taken over by his associate, G.K. Sabinin. It had a main rotor in the center and a small torque control rotor at either end. They were powered by two engines of 120 horsepower each. It was difficult to control and vibrated badly on takeoff. The test pilot was an experienced engineer named Cheremukhin. His only previous experience in helicopter flight was on a rotor test rig at Tsagi. When the front rotor was removed, the helicopter was successfully flown for 12 minutes to an altitude of 328 feet. In June 1932, it crashed, but it was repaired, and the following August it reached almost 2,000 feet before Cheremukhin lost control. In 1935, Stalin arrested a group of leading helicopter designers and engineers. He did more damage to Soviet helicopter development than any test flight crash. In 1944, Alexander Yakovlev became involved in helicopter design. By that time, the leading Soviet helicopter designer was Ivan Bratukhin. But Yakovlev's first helicopter was reasonably successful. It had two coaxial rotors, a system used very successfully by another designer, N.I. Kamov. Yakovlev's second design, the Yak-100, was virtually identical to an American helicopter, the Sikorsky S-51. It flew in 1948 in competition with the designs of two rivals, N.I. Kamov and Mikhail Mil. In spite of good test results, the Yak-100 was not accepted for production. Mil's M1 was adopted instead. Yakovlev's main contribution to the Soviet helicopter was the Yak-24. Design work began in 1953 and was obviously influenced by the twin-rotor helicopters of the American pioneer Frank Piasecki. At the time it made its public debut in 1955, it was the largest helicopter of its type in the world. It established several load records. On this flight, it lifted a 4-ton cargo of sandbags to an altitude of 6,500 feet. The Yak-24 was known in Russia as the flying boxcar. NATO gave it the code name Horse. The two Shvetsov radial engines were mounted in the front and rear of the helicopter. The flight engineer had access to them for inspection while the helicopter was in the air. The Yakovlev flying boxcar was one of the major Soviet military vehicles of the 1950s. There was also a civil version that could carry 30 passengers. But Yakovlev's bureau was not destined to become a major designer of helicopters. It was overshadowed by the Mil bureau, which was to become the colossus of Soviet helicopter development. Mikhail Mil started work on helicopter design with Tsagi in 1920. After the Great Patriotic War, he was made chief of a design team with the task of producing a general communications helicopter. Design began in 1947, and a year later a prototype was ready for testing. There was a crash on the first flight, but two more prototypes were ready, and from that point on the program was highly successful. The Mi-1 was the first of what was to become a great Soviet helicopter dynasty. In 1951, the Bureau built the Mi-2, a slightly enlarged version of the Mi-1. It was the Soviet Union's first turbine-powered helicopter. It was produced in 4 different versions: transport, air ambulance, cargo carrier, and this one, which had a special application in Soviet agriculture. The agricultural version was particularly useful in the parts of the Soviet Union that were frozen in winter. Soviet agricultural theory promoted the advantages of early spring fertilization. But in early spring, ground in the Soviet Union can be very soft, unable to support tractors and heavy agricultural equipment. Small helicopters like the Mi-2 were the only means of effective early spring fertilization. The system worked. Soviet agricultural surveys showed that early spring fertilization increased harvest by 25%. In August 1952, the Mi-4 flew for the first time. It was the largest mill helicopter so far and was immensely effective from the beginning. Its weight-to-altitude performance was excellent, and it successfully established 3 international records. It also set an international record for speed in a closed circuit. The Mi-4 was the start of the Mill Bureau's concentration on large single-rotor helicopters, and it was subjected to some extreme tests. For a single-rotor helicopter of the time, it could lift very heavy loads. 14 fully equipped troops or a Soviet command truck. NATO called the army version the Hound A, but it had many other roles beside the military. The potential of the helicopter in Soviet conditions was quickly recognized by the leaders of the Soviet Union. Helicopters could reach places within Soviet borders that had previously been inaccessible to everything but ships. In winter, some of these places had not been accessible at all. The helicopter was quite capable of operating from the deck of an icebreaker in the far northern reaches of the Arctic Sea. It was a challenge to the Soviet helicopter industry to design and build machines that could operate effectively in these extreme conditions. By the end of the 60s, 3,500 Mi-4s had been built. They were used for agricultural work and as feeder airliners by Aeroflot. In that configuration, they could carry 20 passengers. All of them could be fitted with floats and with a crane that could lift 440 pounds. The ability of helicopters to do jobs that had never been possible before created demands that exceeded the capacity of medium-sized helicopters. The Mi-4 was a large helicopter for its day. Its rotor diameter was 15 feet greater than its American equivalent, the Sikorsky S-55. Its maximum takeoff weight was 17,000 pounds, more than twice as much as the S-55. But the need for helicopters with even greater carrying capacity became clear, and Mill Design Bureau was thinking big. When the Mill Mi-6 was revealed publicly in autumn 1957, it was the biggest helicopter in the world by a significant margin. The fact that it had only a single rotor made it an extraordinary achievement for the Mill Bureau. The Mi-6 brought new meaning to the term heavy load when applied to helicopters. In October 1957, it established 2 weight-to-height records, lifting just over 10 tons. But eventually it doubled this record, lifting 20 tons to a height of 9,000 feet. It could carry loads externally or inside its fuselage. It was used by the military to carry heavy equipment or up to 120 fully armed troops. It was used by Aeroflot to transport 65 passengers, and it was used for firefighting. When a well exploded in a remote Soviet oil field, it caught fire and became a major problem. The fire burned for many months. Soviet authorities were concerned about the wastage of a valuable resource, but in the impenetrable woods and swamps of the far north, there was little they could do. Giant Mi-6 helicopters were brought in to assist in the effort to extinguish the flames. It was extremely difficult. A new derrick had to be set up. Then diagonal holes had to be drilled down to the main gas line and a heavy concrete mixture poured in to put an end to the fire. The Mi-6s carried in all the heavy equipment necessary to do the job. As time passed, the fire gained a stronger hold. When the Mi-6s finished their work, the holes were drilled and the concrete mixture pumped in. Eventually, the fire that had burned at frightening intensity for months was brought under control. In the Mill Bureau's evolution of giants, the Mi-7 was something of an aberration. It was a tiny helicopter powered by ramjets on the tips of the rotors. The Mi-8 was not particularly large. It was about the same size as the Mi-4, but it was a giant in terms of numbers built. It was shown publicly for the first time in 1961 and is still in service. More than 8,000 were produced for a combination of military and civilian uses. Its prime military purpose was to set down assault troops, equipment, or supplies behind the enemy lines. Specialized versions were developed for electronic warfare. But it also had major applications in construction and industry. It could carry 6,600 pounds of cargo on an external sling. Its extremely sophisticated autopilot gave it yaw, roll, and pitch stabilization under any flight conditions. It also stabilized altitude in level flight or hover and could maintain a preset flying speed. The Mi-8 is a classic Soviet helicopter, tough, able to lift great payloads for its size, and equally useful for military and civilian application. The complete Mi-10 flying crane made its first flight in 1960 and its first public appearance a year later. The flying crane's ability to lift heavy loads was enhanced by the design of its landing gear. It was tall enough for the helicopter to taxi over its load. This allowed it to carry bulky objects like prefabricated buildings. It also had a system of interchangeable wheeled cargo platforms to support the load. In this case, a bus is sitting on one of the cargo platforms. The helicopter taxis over the top, and the platform is attached to the landing gear of the helicopter by built-in hydraulic fasteners. These fasteners clamp the load and then raise it underneath the helicopter until it is supported rigidly. Alternatively, if the load itself can be fitted with special clamps, there is no need for the platform. The platform could carry a payload of about 12 tons. The main cabin inside the helicopter could carry 28 passengers or freight. Even with the platform attached to the helicopter, unloading a vehicle was extremely simple. A ramp was attached to the front of the platform and the vehicle was able to drive away. There was no need for the platform to be detached from the helicopter. The Mi-10K, a short-legged version of the flying crane, was built for use at construction sites. It had more powerful engines and a control station under the fuselage for the crane operator. This twin-rotor helicopter is the most extraordinary ever built in the Soviet Union or anywhere in the world. It's the Mi-12, the world's largest helicopter. The Mi-6 and the Mi-10 were, by Western standards, giants. The fact that they used only a single rotor made them even more remarkable. In effect, the Mi-12 was virtually two Mi-10s slung side by side. The design took two pairs of Mi-10K engines and mounted them at the ends of the wingtips on either side of a fat fuselage. Each pair of engines powered an Mi-10 rotor 114 feet in diameter. You can get an idea of the size of this giant by comparison with the 70-foot wingspan SB-2 bomber of the 1930s. This side-by-side twin-rotor arrangement was not new to the Soviet helicopter industry. In the 1940s, Mill's rival, Bratuchin, designed and built several helicopters using twin outboard rotors. But their flying qualities were considered to be inferior to either single-rotor or coaxial designs. In early test flights, the Mill Bureau must have wondered about the wisdom of its decision and the stability of the twin-rotor layout. Certainly, the cameraman was not impressed by the plunging giant. The Mi-12 was a contemporary of the giant AN-22 Antheus transport aircraft. In fact, it was seen as the AN-22's vertical takeoff equivalent. The vast fuselage had two flight decks. The main deck accommodated the pilot, engineer, and electrician. Above it was a smaller one that housed the navigator and the radio operator. The cargo hold had rear doors to allow access to vehicles or other heavy loads. It had a built-in electric traveling crane system that could lift 10 tons. Inside the hold, there were 50 fold-down seats around the walls for crew accompanying the cargo. The prototype flew for the first time in 1968, but the West did not become aware of its existence until 1969, when it carried a 40-ton load to a height of 4,500 feet. The Mi-12's major safety measure was a series of cross shafts in the wings which interconnected the four engines. If one engine failed, both rotors would still operate and the helicopter would stay in the air. It was designed to work even if a pair of engines on one side of the aircraft failed. In 1971, a development version of the Mi-12 visited the Paris Air Show, where it raised the eyebrows of Western helicopter manufacturers. But after it returned to the Soviet Union, little more was heard about it. There were reports that it entered service in 1973, but it remained something of a mystery. In fact, the Mi-12 project had been cancelled. The Mi-12 failed to fulfill the hopes of its designers. The reputation of the Mill Bureau continued to grow, but it was based on the evolution of its single-rotor designs rather than this twin-rotor giant. In the mid-70s, Mill developed another highly original helicopter. The Mi-14 was a true amphibian. Most helicopters can be fitted with floats, but the Mi-14's hull, designed like that of a flying boat, was its means of flotation. The Mi-14 could land and take off from choppy water. It also had retractable landing gear, so it was equally at home operating like a conventional helicopter. The Mi-14 was a development of the Mi-8. It's the equivalent of Western helicopters like the Sea King, and its primary function was anti-submarine activity. The Mi-14 is known by NATO as Hayes. It flew for the first time in 1973 and was accepted for service in 1976. After the failure of the giant twin-rotor Mi-12, Mill began development of another heavy-lift helicopter. This time, they reverted to single rotors, but with a difference. The Soviet Union was well in front of the West in giant single-rotor technology. The components of this new helicopter were radically larger than anything comparable in the West. This is a set of basic parts for the main reduction gear of the giant new helicopter to be called the Mi-26. The reduction gear alone weighed almost 4 tons. It was only slightly heavier than the same assembly on the Mi-6, but was expected to cope with 1.5 times as much torque. It was exhaustively tested on a closed-circuit bench. With this ingenious device, the parts could be tested using only 1/20th of the power capacity of the helicopter. The engines planned for the Mi-26 were 2 Lotarev turbo shafts. They were much more powerful than those in the Mi-6, 8,500 horsepower each. They would be coupled to drive the single rotor through this system of reduction gears. As testing on the closed-circuit bench proceeded inside the Moscow helicopter factory, The main reduction gear and the engine and tail transmission were tested on a normal rig set up outside. The rotor diameter of the Mi-26 was to be 9 feet less than its predecessor. Mill was depending on increased rotor efficiency to give the greater lifting power they were expecting from this new helicopter. But at this stage, the new rotor was not available for testing. The main blades of an Mi-6 rotor were shortened and installed on the test rig. Aerodynamic brakes were added to the blades. Eventually, the new Mi-26 blades became available for testing. This was the crucial part of the helicopter's development. Soviet helicopter engineers understood the difficulties they faced. They have a joke which says that any other problem in aviation can easily be placed on the tip of a helicopter's blade. They were trying something the rest of the world said was impossible. Western designers believed that if a main rotor had more than 7 blades, efficiency would drop. But designer Marat Tishchenko knew better. He decided on a rotor with 8 blades. At this stage, construction of the fuselage of the giant Mi-26 was not complete, so the rotor was installed on an Mi-6 testbed. The Moscow helicopter factory also used another Mi-6 for tail rotor testing. It was unofficially named Carlson, after a Russian storybook character, a fat gnome with a propeller in his back. The tail rotor of the Mi-26 was to have 5 blades. The main reduction gear of the Carlson was modified to deliver the equivalent of 8,000 horsepower to the small rotor, eliminating the need for a special test rig. In spite of the power being fed to the tiny blades, there was no question of Carlson's leaving the ground. The Mi-6, fitted with the new advanced rotor designed for the Mi-26, began a series of test flights. They put the rotor through its paces well before the new fuselage was available. It was tested over the new helicopter's range of operation at maximum speed and maximum cargo weight. The general design calculations for the new rotor were confirmed before the complete helicopter was available. The new design was found to be much more efficient than the old Mi-6 rotor. This is by far the best-known Mill helicopter in the West. It's the legendary Soviet gunship, the Mi-24, known by NATO as the Hind. Originally, the Mi-24 was designed as a troop carrier. Its purpose was to deliver 8 fully equipped assault troops into the battlefield. Its weapons were designed to support this function. They were meant to clear a path through enemy resistance. Soviet military authorities had carefully studied the performance of American helicopters in the Vietnam War. They were impressed by the record of gunships like the Huey Cobra in supporting other troop-carrying helicopters. The idea of a helicopter with a role rather like the legendary Sturmovik aircraft of the Great Patriotic War was appealing. They recognized that in modern warfare, a heavily armed and armored helicopter could be extremely valuable. But there was a catch. Soviet military doctrine did not allow the construction of a dedicated attack helicopter like the American Huey Cobra or the Apache. Heavy armament and armor had to be combined with the ability to carry troops. This meant that the Hind had to be large, much larger than any of the gunship helicopters operated by the United States, France, or Britain. Initial development of the Hind was slow, because a great proportion of the resources of the Mill Bureau were committed to the development of the giant Mi-12. But once that project was cancelled, the way was clear. In designing the Mi-24, Mill utilized features of many of its proven designs. It had small stub wings like the removable ones on the Mi-6. They would provide lift at high speed and be able to carry weapons. Its retractable landing gear was developed at the same time as that of the Mi-14 amphibious helicopter. They were the first Mill designs without fixed landing gear. The fuselage was based on the Mi-8. It was a conventional all-metal pod and boom. In the late 1960s, Mikhail Mill, the head of the Mill Bureau, was terminally ill. He had cancer. The Mi-24 project was placed in the hands of Marat Tishchenko. Early test versions had excellent agility and all-round performance. The first examples seen by the West did not have the gunship-style tandem cockpits. Instead, they had a large four-place flight deck. The tandem cockpit version was not seen in the West until 1975. Although it was called Hind D by NATO, it was clear that this had now become the basic production model. In the Hind D, the weapons system operator sits in front with the pilot behind and at a higher level. The weapons system itself is comprehensive and sophisticated, with a 12.7mm cannon in the nose turret and rockets and anti-tank missiles mounted on the stub wings. It uses radar and laser guidance systems. Since production began at Rostov-on-Don and Arseniev in the early 70s, Hind Ds have been produced in their thousands. For the first 10 years, production was maintained at an average of 15 a month. From the start, the operational qualities of the Hind were excellent, and they quickly became very popular with crews. Most Soviet helicopters up to that time required considerable physical effort to fly. The Hind was different. For a large helicopter, it was extremely agile, and its fighter-like handling was accompanied by unusually light control forces. In the early days of their life, the Hinds were not tested in battle. Their performance in large-scale military exercises was excellent. Eventually, in the Soviet war with Afghanistan, their reputation as a combat helicopter was confirmed. Design work on the Hind began in the mid-60s. By the late 70s and early 80s, there had been major advances in helicopter technology. New composite materials, light and strong, could take the place of much of the traditional metal structure, particularly in rotor blades. At the Mill Design Bureau, a great deal of effort was directed towards developing systems to test these new materials. These are benches for dynamic testing of new technology, stability augmenters, main and tail rotor heads and hubs, and bearings of new design and new materials. Much of this technology was a radical departure from traditional Soviet helicopter construction. Thorough testing was considered essential. There's a bench test for every part that needs to be subjected to the forces it will experience in sustained flight. Main and tail rotor blades are tested, and so are air intakes, tail booms, and fins. This is a new test bench created by Mill for repeated static testing of the strength of airframes. The airframe of a new Mi-34 is being subjected to a series of drop tests. The same test is applied to an Mi-26 heavy lift helicopter. In the late 70s, these developments in materials and electronics were applied to the design of a new Mill combat helicopter. Strictly speaking, it would not be a replacement for the Hind because its function would be different. The major shortcoming of the Hind was the fact that a large helicopter makes a large target and it was vulnerable to ground fire. In designing its successor, the Mill team started from scratch. The new helicopter would not have the Hind's multi-purpose flexibility. It would be a two-place attack helicopter. It would be smaller, slimmer, and less vulnerable. NATO gave it a daunting code name. They called it the Havoc. The #1 prototype of the Havoc flew for the first time in 1982. Progress was slow on the initial flight test program of this deadly new Soviet weapon. Only a limited number of prototypes were funded. Although it was a new design, the Mi-28 drew extensively on the experience of the Hind. Its rotor blades were virtually identical, except that they were made from composite materials. The Mi-28 was powered by the same engines as the Hind, two Izotov turbo shafts of 2,200 horsepower each. The Havoc is smaller than the Hind, but it's still a large helicopter. Its takeoff weight is more than 11 tons, which makes it about 20% heavier than the American McDonnell Douglas Apache. It is maneuverable, capable of performing a full loop. The Hind's design speed was just over 180 miles an hour. The Havoc, with similar engines and rotor, is slightly faster. In the course of a flight test program, it exceeded 300 kilometers an hour in level flight. That's about 186 miles an hour. Like all military aircraft approaching maturity in the last years of the Soviet system, the Havoc has an uncertain future. Originally, it was planned to go into full-scale production in 1991. Those plans were delayed by the collapse of the Soviet system and of the Russian economy. The Mill Bureau set out to design a frontline helicopter to defend the Soviet state. For years, military observers in capitalist countries coveted the fearsome Hind. They may now have the opportunity to acquire its successor on the open market. Soviet helicopters showed their value and versatility in the aftermath of the Chernobyl nuclear power plant disaster. Dozens of helicopters made continuous flights over the damaged reactor and dropped lead and silicon oxide into the crater. Other helicopters airlifted thousands of tons of equipment to be used by ground rescue workers. Among them was the huge Mi-26, the world's largest heavy lift helicopter. This is the Ka-32, a recent helicopter produced by Mill's greatest rival in the Soviet helicopter industry, the Kamov Design Bureau. While Mill specialized in the production of single-rotor helicopters, Kamov made its reputation with a completely different system. Since the 1950s, Kamov helicopters have used twin rotors. In most cases, these rotors have been arranged coaxially. They rotate around the same shaft. They are placed one above the other, and they each turn in opposite directions. This means that there's no tendency for the rotor to twist the helicopter itself. It's a very stable system. While Mill have pursued great size and lifting capacity in their designs, Kamov have concentrated on developing small, compact helicopters. Their layout and efficiency has made them particularly suitable for operation from ships. They've been used for anti-submarine activity and missile guidance, and in civilian life for agriculture and ambulance service. Between them, Kamov and Mill have almost succeeded in proving the statement that the Soviet Union was specifically invented for the helicopter.
Fish is winning right now.
Doveva essere un pesce veramente grosso.
Broke his pole.
Ma che bel posto, a me, in riva al fiume. Tranquillo. Beh, tranquillo, è appena passato un elicottero. Grazie, Piccolino. Piccolino, vieni. Aia.
Il tonno. Ecco, adesso i tonni in mare sono due. Ed ora occhio allo squalo. Ed ora le parti si invertono. Lo squalo in barca e il pescatore in acqua. Attenti a questo pesce, non ne vuole sapere di essere catturato. Vedete? Lo prende a pesciate in faccia.